It's an interesting problem. 9 raised to power 9 minus 8 raised to power 8 upon 1001. The only purpose of solving such problems is one, you are preparing for Olympiads. Second is that these kind of problems are really fun problems. They will expand your textbook knowledge of maths. So it is always good that you off and on you should go through these problems. Pretty interesting problems. Actually, this problem is class 9, class 10 level, not beyond that. So let's start looking at the solution of this problem step by step. So whenever I look at something raised to power something minus raised to power something, at least for me, the first bell that rings is it should be a square minus b square, or a cube minus b cube, or a raised to power 4 minus b raised to power 4. And that is why I'm telling you that this is actually a class 9, class 10 level problem. So I know something has to be done regarding a square minus b square, a cube minus b cube, a raised to power 4 minus b raised to power 4. At least that I have. And when I look at 1001, so you know, if there is something happening in the numerator, in the denominator, how do I reduce a number to a manageable numbers? The manageable numbers can only be done if I prime factorize this number 1001. When I do the prime factorization, uh, the the multiples that I get is 7 into 13 into 11. Now, the numerator, when I look at the numerator, I need the numerator to be, either in the somehow either of these three numbers, 7, 13, or 11. So that, I can do some cancellation. So right now I have two clues. One is it would be some expansion of some expansion. The second is the expansion should have a common term, uh, which should, chop off from the denominator. So either it should be 7 or 13 or 11. So I'll do some hit and trial, and then I'll come to some conclusion, and let's look at how the problem is solved. So this 9, I can write this as a 3 square. This 8, I can write it as a 2 cube. Now this is the basic, indices. Indices, you should have a thorough knowledge of indices, and that too of class 9 level, not beyond that. So once I have written 9 as 3 square and 8 as 2 cube, then uh, uh, one thing that starts making some sense to me is that if I write this 3 square as 27 and this 2 cube as 16, so 27 and 16 are the two numbers that I have. And then once I apply the expansion, that something like 27 minus 16 might come. So when 27 minus 16 comes, I understand that that is 11, and that I have a 11 here also. So this is how I have solved. You might have some other better way. Please share in the comments if you have any better way. So I write the 3 square as some form of 27. So that is 3 cube. I write 2 cube as some form of 16. And then 9 to the 18, 6 3 the 18, and 8 3 the 24, and 6 into 4 24. So my indices are working perfectly. So finally I come to this conclusion that this is 27 raised to power 6 minus 16 raised to power 6. And when I apply the expansion, it would be 27 minus 16, and the 11 in the numerator and 11 in the denominator will chop off. Now, what do I do with this expansion of a raised to power 6 minus b raised to power 6? And then, you know, this is the next step. In the next step, I know that a cube minus b cube is the expansion a minus b into a square plus ab plus b square. This I know from class 9. And a6 minus b6. So therefore, a6 minus b6 can be written as a square minus b square into a4 plus a square b square plus b4. I hope you understand this step. If you have any doubt, please let me know. I'll explain in the comment section. From here to here, I hope you are able to understand. If there is any doubt, please let me know. I'll explain in the extension in the comment section. Now, a square minus b square can be written as a plus b into a minus b, and a4 plus a square b square plus b4 can be written as a square plus ab plus b square into a square minus ab plus b square. Again, if you have a doubt in this, you can ask me. I'll reply in the comment section. So the new thing that we have, most of you would have learned today, is a6 minus b6 can be written in the form of this. This is a modification of one of the question which was, as I gather, was asked in Harvard exams. So a6 minus b6 can be written as a plus b into a minus b, a square plus ab plus b square into a square minus ab plus b square. So trust me on this. If you have any doubt, ask me. I'll reply in the comment section. So our original 27 raised to 6 minus 16 raised to 6 can now be written in as 27 plus 16 into 27 minus 16. Now, people who are with me till here would understand that 27 minus 16 is 11, and this 11 will get chopped off with this 11 which is there in the denominator. So now this is 27 square plus 27 16 plus 16 square, 27 square minus 27 into 16 plus 16 square. So 27 plus 16 is 43. This 27 minus 16 is 11. Now this is here is where we'll use brute force. But the good news is that once I've calculated 27 square and 16 square and 27 into 16, then it will be repeated in both the terms, the third term and the fourth term. So once I calculate, this will be 1417 and this will be 553. So you reach till here. This is what I have reduced my numerator to. So this is my numerator, uh, 43 43 11 1417 553. I have, this is my numerator, and denominator is 7 13 11. So 11 and 11 chops off, and then I do the simple calculation, and then I multiply 43 109 79, and the answer is 370 273. Now this is a bit of modification because in the original question they had just asked for the summation of the three factors. They had asked for 43 plus 109 plus 79. I've modified it a bit. So the answer is 370 273. Now, you know, that is what I was trying to tell you in the beginning of the question, in the beginning when we started the solution. So this is something which will sort of expand your current knowledge. You'll understand uh, more and more questions like these you do, the more sort of builds your mental stamina to how to approach the difficult questions. So I hope this was useful, and we'll meet in the next video. We'll do similar interesting question. I hope you liked it. Please do comment if you have a better solution. I'll be glad to read your comments. Thanks a lot, and best of luck.